Hey everyone, welcome to this video. So in the previous video about loss, we talked about how from this picture, it is fairly obvious that to get the lowest loss of 0, we need weight values of 2. But how would this be discovered during training? To start off, let's randomly pick starting weights of 0, which gives a loss of 4. And to get weights that minimize the error/loss, should we go to the left, which is decrease the weight values from say 0 to -1? Or should we go to the right, which is increase the weight values to say 1, 2, 3, 4, 5, etc.? Again, with our eyeballs, it's fairly easy that for the loss to go down, we need to go to the right, increase the weight values. But how would we do this with math? I'm sure you remember from middle school or high school math about the slope, but here's a refresher. The slope is the change in y over the change in x. So here I've graphed y equals 2x. Every time x goes up by 1, y will increase by 2. So the slope equals 2. What I want you to remember is that slope equals rate of change. So randomly pick starting weights of 0, which gives a loss of 4. Find the slope, which here is this orange dotted line. And the slope identifies where down is, the minimum. I want you to imagine that this orange dotted line, the slope, is like a hill or a mountain. Now, for this hill or mountain, which way is down? To the right. We need to increase our weight values to go down. Let's go to the right or increase our weight values by 3. There we go. Weights of 3 gives a loss of 1. Find the slope, again this orange dotted line, which you can think of as a hill or mountain. And now for this hill/mountain, which way is down? Going to the left or decreasing the weight values. So let's decrease the weight values by, say, 1. There we go. Now we're at 2, which gives a loss of 0. So yeah, weights of 2 gives a loss of 0. Find the slope. And now we have a flat hill or a flat mountain, so to speak. If that's a real term you can use, a flat hill or a flat mountain. And the minimum has a slope of 0. So what goes on in gradient descent? Let's review. Number 1, randomly pick starting weights. Repeat until we reach minimum loss. Find the slope. The slope identifies where down is. Think of the slope as like a mountain or a hill to show you where down is. Update weights. So the slope is the rate of change. The derivative is like a mathematical way to find the slope. And the gradient is a multi-dimensional derivative. Let's talk about the forward pass. Number 1, get the outputs. Number 2, calculate the loss. I have 2 diagrams here to demonstrate what happens in a forward pass. I find the second picture or diagram to be more obvious. The inputs go through the model. The model gives us the outputs using its weights. The outputs is used to calculate the error/loss. Then backpropagation, send the loss backwards to find the gradients using calculus. Now, I don't know calculus, so we will not go over the math being used here. Just remember that in backpropagation, loss is used to find the gradients. Okay, so let's be more precise about what is going on in this diagram for training. Number 1, randomly pick starting weights. 2, repeat until we reach minimum loss. Forward pass, get outputs, calculate the loss. Backpropagation, send the loss backwards to find the gradients. Then do gradient descent to update the weights. And then by the time we reach minimum loss, hopefully we have optimal weights so that our model is now really good at determining if this is a picture of a dog versus a picture of a cat, or whatever it is your model is trying to accomplish. And remember that we ran this model or file earlier on in the course for classifying digits of, okay, this is a 3, this is a 5, this is a 7. Now, instead of running until we reach minimum loss, I have my code run for 10 epochs. But as you can see, in a forward pass, calculate the outputs, calculate the loss, in back propagation, compute gradients, update weights. And during training, we can clearly see that the weights improve because we go from a training loss of 0.45 to a training loss of 0.06, a validation loss of 0.28, and then the weight values improve enough so that the validation loss goes to 0.08. So yeah, that's it for this video. Thanks for watching.